Byrne, I didn't know you were into meditation.
I'm trying to master complete control over my body.
Like, what do you mean?
Every system, we have an involuntary system. I'm teaching myself to control it.
Oh.
Check this out. I'm going to try and stop my heart.
Oh. Byrne? Are you okay, man? Byrne? No, he's fine. Oh, well, it looks like I better get the permanent marker then. Our next guest is a neuroscientist turned comedian. During the day, he's looking at involuntary action, but if he's not watching people's brains light up, he's lighting up the stage at the Melbourne Comedy Festival. Please welcome David Farmer.
Oh, g'day, guys.
How are we, Doctor?
Very well, mate. How are you?
I'm very well. So you've been a bit busy lately at the Melbourne Comedy Festival.
Yeah, I did. So I had I debuted a show.
Oh, the D-butt.
The D-butt.
Yeah.
To unbutt something. The show was called Why You're Not Dead Yet. It was a show about, I think we built it as a comedy, storytelling, infotainment mash.
Oh.
About the brainstem and how the brainstem stops you from dying moment to moment. This is an ancient part of the brain at the base of your skull that doesn't have much to do with who you are, how you feel, or consciousness, or memory, or any of that stuff, but how your body is coordinated moment to moment, your organs, your heart, the rate of your breathing, just to stop you from dying. Not like month to month, but moment to moment, your brainstem does these things so that you don't just collapse. And
Not just dying on the inside, literally dying.
Literally dying.
Yeah, okay.
in a not existential way, like an actual way.
Not a made-up kind of way.
Yeah, that's right. Yeah.
Oh, that's awesome. And you sold out 3 nights of the show too, which is awesome.
It was really nice. I was relieved when that happened. It makes it a lot easier. So this is actually, I should say, this is the first time I've done a show like this. I've done a bit of performance before, but this was the first time I built something. It was like me and my pal Jackson, who is actually a comedian, who is my support and my other half, and a great guy.
Well, he can't be that great. He's not here today.
He's on a Bucks, I think.
That's right. Yeah, we got that. We're like, I would totally prefer to be on a Bucks and get interviewed by
That's
two
fair. We are
dickheads.
down in Melbourne. This is where we had your Bucks down here, Wade. So
We did.
You know how you feel about Melbourne Bucks. It's fair.
Yeah. No, that's a fair call.
And he's on a Bucks at 12 minutes past noon, so I feel like he can be excused.
Yeah, fair enough. Let's start early.
Yeah, so selling out the show, like when you've got something, doing it for the first time, knowing that there's going to be some people there and that they've paid to listen to you and that the doors are locked, makes it all a lot easier.
That's fantastic. And did you have to transfer like your own state? Because obviously you're a neuroscientist, so you primarily look at involuntary actions?
Yeah, that's exactly right. So I'm interested in... So I'll give you an example. So your brain... What do I want to say here? So your brain coordinates the functions of your organs so that you don't die, right? And that makes it sound simple. It's not just It's not just controlling your organs. It's coordinating them, and it's coordinating them in a variety of different circumstances. So, for example, if you go from sitting quietly and you're breathing at a particular rate, and your heart's going at a particular rate, and X amount of blood's going through your heart minute to minute, and then suddenly you see a bear or some other large alarming stimulus, then the fancy, cortical new bits of your brain are going to do something really, sensible. They're going to make you terrified and, try to remember any other instances where you encountered a bear or what you're supposed to do in that situation or what's going on. And, ultimately decide whether to fight it or to run away or what to do. You should probably run away, I reckon.
Yeah, I wouldn't want to fight a bear.
Yeah.
I can't see myself coming up on top. Maybe like a panda. I reckon might be able to take a panda. They seem kind of docile.
They do. I feel like you just push him over.
Those red pandas.
Yeah, red panda. One of the little bears. Yeah. Grizzly get messed though, right?
I feel like the red pandas have got it particularly bad because they're just as docile, but they're the color of anger. So
Next time Per goes, he's going to jump the fence and kick a baby bear.
Yeah, I just need to know now. It's like, for science, I have to fight this red panda.
You're welcome, Earth. So your higher brain's doing all this stuff to decide what to do, but your lower brain, so the ancient parts of your brain, the brainstem and the hypothalamus and these spots, they're doing something equally as important. What they're doing is coordinating your organs so that you can deal with this new situation. Okay. So the brainstem and the hypothalamus will speed up your heart so that there's more blood going through your body. It'll dilate the blood vessels in your muscles so that you can use them to fight or to run away more effectively. It'll constrict the blood vessels in your guts because you don't need to digest a sandwich if you're in danger of yourself being digested by a bear. So that's what people call the fight or flight response, right? But that kind of makes it sound simple, but it's not one response. It's a coordinated series of responses that you need a quite complicated bit of computer to do. And that's what the brainstem and the hypothalamus and these basic areas of the brain do.
So you referred to the part of the brain you look at as being kind of a little bit more primitive. Does that mean the other parts of our brain have evolved later? Is that...
Yeah, so I'm not an evolutionary biologist, but I have read a little bit about this. So my understanding of it is that once you're an organism who's big enough and complicated enough to need some kind of brain structure, so like one of the first brain structures that would have evolved would have been the spinal cord and the brainstem to do things, these very life essential things. Like if you're an organism who needs a heart and to breathe, then you need to control and coordinate those things so that you don't die. And then it's hard for evolution to change that because if you need to breathe to live, then if you evolve the ability to shoot laser beams out of your eyes or something else amazing, if it breaks your ability to breathe, then that organism won't survive and that gene won't be passed on. So my understanding of the evolution is that you have these basic brain structures and then all you can really do is add on to them. So you have these very basic structures, and then as you come further forward and through the midbrain and the hypothalamus and the thalamus and then the cortex and the neocortex, you have increasing complexity, and sometimes you can mess with the function of the stuff downstream, but you can't break it. You can't inherently break your ability to breathe or to control your organs because you're not likely to survive past birth.
Yeah.
So yeah, my understanding is that they're more primitive areas because once they exist and once you need them, anything new can't break them. It can be awesome, but as long as it doesn't break those things.
Isn't it also referred to that brainstem as the reptilian?
Yeah, like the brainstem and the pons, that's my understanding as well.
Yeah, okay.
It's got a name, it's like the tyrule brain or something, or tyrule brain.
Oh, man.
Don't look away to ask that. Yeah,
I'm just rattling off old pictures from uni.
That's right. So, doing your research, you looked at coughing.
Yeah,
and
that's
the
right.
involuntary response of coughing.
Yeah.
So my question is, why do doctors feel the need to grab your testicles and then make you cough? What's the relationship there?
I have absolutely no idea. I mean...
And why did you feel the need to grab our testicles when you walked in?
Just... I'm in a hotel room, it's just something about the light and the light from the open bar fridge and...
No, yeah, because we're kind of thinking that because it's usually it's fucking ridiculous. The first question Byrne and I thought, I was like, he's a neuroscientist. He looked at coughing in the past. And I'm like, oh, okay. Why do nurses grab people's nuts when they cough?
This is really saying more about us than anything else. To be honest.
I know, yeah.
See, so I'm wondering. I don't know if it's related. I don't know if it's and now cough and I'm gonna feel the cough through your whole person.
Yeah, is it the brainstem that coordinates the rising of the testicles along with the coughing?
I don't explicitly know, but I suspect so. I suspect that's under brainstem control.
Yeah, isn't it like when you play sport and stuff like that, or you're in a fight, that's when your nuts kind of shrink up? Or unless my nuts are just naturally small.
And that's why they shrink up permanently.
And like your penis size doesn't grow any bigger than like 2 centimeters. Am I right, guys?
Because of the brainstem? Because of my brainstem?
Because of the brainstem.
Please tell me it's the brainstem.
So here's what's cool about cough, right?
Yeah.
Cough is cool because it's not breathing. So at the moment, not right now because I'm talking, but if you're just sitting quietly breathing or you're asleep or in a coma or blackout drunk, you mostly continue to breathe. And the reason that you mostly continue to breathe is because your brainstem's in charge of your breathing muscles in your chest, right? So these cells in your brainstem that are in control have a rhythm. They generate a rhythm, right? This tick-tock that's breathing in and breathing out. So when you have a tick-tock rhythm in your brain cells that control breathing, you have a tick-tock rhythm in your breathing muscles, and that in and out, even if you're not paying attention to it, is what breathing is. So that's clearly really important, right? Because if you stop doing that for a few moments, then you die. Like if you stop breathing for 5 minutes maybe, and then you're in serious trouble. So it's therefore pretty weird that you can produce other patterns of activity in those same muscles. You can override this life essential act of breathing in order to do other stuff. So one of the things you can do is cough, and it involves exactly the same muscles as breathing, but you're just activating them in a different order. So, for example, one of the reasons you cough, and one of the reasons that the brainstem particularly will make you cough, is you have sensors in your windpipe which are very, very sensitive to touch and to particular chemical compounds. And if you switch those sensors on with, say, chicken parma or a piece of Lego, then those sensors are activated, that information sent to the brainstem, which immediately produces, just a spluttering, immediate reflex cough. So that's kind of cool because it's not a conscious decision, but your brainstem is making a decision about what to do based on what's happening in your windpipe. It detects so if these touch sensors are activated in your windpipe, that information goes to the brainstem, and the brainstem makes a decision. It decides you need to stop breathing and you need to start coughing because there's something in your windpipe. And so that's a decision that's being made at a completely unconscious level based on what's happening in our bodies that involves coordination of lots of different muscles. And it all happens in the brainstem without any kind of conscious control.
And instantly, and it overrides your normal functioning.
Exactly. I mean, you can't stop it. You cannot suppress that.
It's kind of weird to think how little control we actually have over ourselves. There's something in us that's controlling how much we work.
That's what he tells the courts anyway.
It's not control. It was me. It was my brainstem.
Your Honor.
Your Honor. Yeah, because people can have such severe coughing fits that they can die. Like the elderly.
Yeah, chronic cough is a pretty nasty condition that people do get, and it's very, very poorly understood. And it's a cool area to research. Because there are debilitating diseases that are associated with chronic cough conditions and disorders of coughing, whether it's something in the windpipe or something in the brain. But it's also cool because just from a knowledge standpoint, we're trying to understand how you build a brainstem. How do you use brain cells, neurons, to design a system that can keep you alive? How do you solve problems like I need to breathe, but there's something in my windpipe using neurons and muscles?
Yeah.
And that is still quite a complicated bit of computation and of brain function that we just don't understand. So it's cool from a therapeutic perspective to study this, but it's cool just from a straight up physiology, how the hell do we work kind of way.
Do you think that neuroscience will overtake philosophy in kind of, what is it to be alive and type thing? Do you think the answer lies, the mysteries of life and things like that, or what it is to be alive and to be human and to feel something? Do you think that would be that neuroscientists will find that?
That is heavy, man.
I know. Sure.
Yeah, fuck it, why not?
Yeah. Absolutely. I don't know. I don't know. Here's the thing. Studying consciousness is cool and we should do it, and I'm glad that people are doing it. But it's really, really, really complicated. And we don't understand how the brainstem works. Like, we don't understand how the most ancient part of our brain is organized in order to solve basic problems involving, pressure and fluid movement and really, really basic shit that we need to be alive. Yeah. So it's like we don't understand this calculator, but let's try and understand this crazy supercomputer as well. Okay. I've got a lot of faith in science. That's a bad turn of phrase, isn't it?
Trust maybe.
Trust in science. I believe in the process. I believe in the process of advance. I'm a really strong believer in it. And I think we'll get there. But I guess it depends. If someone can explain to you exactly how your brain works, then you probably have a feeling about that.
Yeah.
If you think about it, you actually start your independent life with a cough. Like when you're born, the first thing they do is give you a smack on the bum and a baby coughs, and then they start breathing. So the first independent action you'll ever do in your life is a cough, and then probably a cry. And then you probably shit yourself after that.
Yeah.
Cleanest shit you'll ever do as well.
Oh, mate, no, it's not. It is rank.
No, like the most sterile shit.
Oh, yeah, it is. But
sterile, yeah.
It's like tar. It's terrible.
It's bad. What's the meconium?
Yeah, that's
meconium?
it. Oh, Jesus. gnarly.
Byrne's a new dad, so
Yeah.
because I think it's mostly bile and other things because you haven't really eaten
Oh, it's
anything at
bile
that
and
point.
pure evil, I think. That's what's in it. Yeah.
Biological evil.
Yeah, that's right. It's amazing. Oh my gosh, they should use that to pave roads. I don't think they would ever break down. Yeah.
So back on to your comedy. How do you get something like science and make it funny? We just make dick jokes, and for some reason people like that, and we just chuck in a whole bunch of science and the odd dick joke. But you get something like neuroscience and kind of like, these really intricate kind of network of
Super
systems
technical
and
terminology.
Yeah. And yet you can sell out venues, with a comedy show about that. How do you go about, where do you start?
So I think you start with a mix of things. So like I say, it was a comedy infotainment storytelling mash. So
You've said that a few times,
right,
haven't you?
I know. It's because before I came here, I was like, you have to build the show as that. It's not a comedy show; it's a comedy storytelling infotainment mash.
Mash.
I knew that if you just start telling people about science, some people want to hear that. Like, some people want to go to a lecture theatre and listen to someone talk about science for 50 minutes. And a lot of people don't. Like, a lot of people, you want to try and reach people who might not necessarily go and see a science show, right? So to do that, I'm gonna come clean. Jackson and I were not above the odd dick joke in the show.
Oh, good. We're on the right track, Byrne.
Yeah, absolutely. So yeah, we kind of built up to the science. So when you're talking about why you're not dead yet and brainstem function, you can also talk about some other fun stuff, like the work of the people who first tried to figure out why we're not dead yet. So they weren't the very first, but in the 18th century, people like Luigi Galvani and Alessandro Volta in Italy, who were dissecting corpses and writing down what they found for kind of the first time in hundreds of years, and learning about the relationship between electricity and life, and thinking electricity was the soul, and going on to inspire Mary Shelley to write Frankenstein. And I mean, there's all these amazing things that have happened as a result of people trying to figure out why we're not dead. That also kind of allow you to explain some basic science concepts, like, why is it that, how does cells work? Why is it that an electric current should cause a leg to twitch? And it's to do with the electrical charge across a neuron's surface. And just talk about basic cellular function and basic brain function in the context of the people who were doing these kind of wild dissections on corpses and trying to access the soul,
Yeah, imagine being a scientist in those old-timey days. I've got this dead guy. We've got this new invention called electricity. I'm going to stick a couple of electrodes in and see what happens. Holy shit, he's moving, That's amazing.
That was quite literally what it was.
What a dream.
Yeah, no.
Stupid ethics boards. Yeah.
If I want to probe a dead guy with electricity, I should be allowed to.
That's right.
Fuck their family.
What do you mean grave robbing? No one's using it.
Grave robbing, schmobbing. So yeah, I wanted to put a little bit of something all over the place. And, I'm a pretty silly guy. I'm a scientist, but I'm at heart a silly and trivial man.
Yeah.
And I think it's important for people who are scientists who feel that way to portray themselves that way. Because especially as a neuroscientist, I mean, when I say neuroscientist to people, they picture, someone in a white coat in an ivory tower with an MRI machine peeling back the curtain on humanity, right? And that's not my day-to-day experience. My day-to-day experience is, practical problems. It's if you want to study brains cells are close together and unspeakably numerous, and all look pretty much the same, are really tiny, and are really squishy. As Jackson would say, if you want to study the brain, you can't just pick it up like a pineapple. It's squishy, and you have to get around those practical problems in order to study it. And that's not hard to understand. Consciousness is hard to understand, but understanding the way that people go about studying the brain is not hard, because the problems are simple. It's squishy. I can't pick it up. I can't dissect it. I need to figure out how to study this thing. And if you can give people an understanding of those problems, then maybe they can have the feeling that they would know how to begin to address those problems. And yeah, that was something that was important to me in the show, was to kind of de-escalate the neuroscientist awe factor. Because, like I say, I'm a pretty stupid, trivial dick joke kind of guy.
Study the brainstem stuff. Is it MRI scans as well?
No, so
Scare people, see what happens? Yeah.
no, so our work, because there's no other way to do it, is usually carried out in animals. So if you want to have a true mechanistic understanding of how the brain works, you have to study brains, and unfortunately, the only source of brains is in living animals. So yeah, we go through pretty stringent ethic controls to make sure that those experiments are being done correctly, but ultimately, we get pretty exciting results from doing these kind of experiments. So, as someone who's interested in organ control, one of the cool things we can do is... So...
Force someone to shit themselves.
Oh, mate.
well,
That's all you want with
Listen
brain.
to the
Every time
scientist
brain-
speak.
yeah. I mean, I mean that there is no reason in principle why you couldn't find the correct nerve and stimulate it and have that wirelessly activated.
Fantastic.
And so like
I hope you'd never become a supervillain.
I don't see you as a supervillain. I think more like just a villain. Maybe just a second tier entry level villain.
Like a henchman or something, yeah.
Yeah, just one that rocks up for one episode that you don't hear from again because the ratings were shit.
Where's Dr. Wade? Shh.
Yeah. It's just we don't mention him. He was
Lab accident.
yeah. It was too creepy and controversial. Sorry, you were saying.
Sorry. So the way that the brainstem controls your organs is that I mean, people. I don't know if people realize this, but if the brain cells, if you want to control an organ with a neuron that's in the brain, so the cell body, like the business bit of the brain cell, is in the brain. But some of them have very, very, very long legs called axons that go all over the body, right? Like telephone wires. So a neuron in the brainstem that is concerned with heart function will send one of these axons or wires to the heart, and when it's activated, the heart will slow down, for example. Mm-hmm. So, I mean, that's kind of cool for one reason, because it means that the cell who's doing that is actually as long as the distance from my head to my heart. So that's a cell that's, microscopic,
So cool,
but it's actually, about 30 centimeters long.
Mm. For Byrne, it'd be 15 centimeters. Sure.
It's okay. It's not the length of the neurons that's the most 100% important thing.
Yeah, that's right.
Also, girth.
Girth is equally important.
The girth of neuron is very important.
It's what you do with it, Wade.
It's the motion in the ocean.
So this is quite handy from our perspective. So it gives us a way of identifying what a neuron's job is. So if you're studying neurons just in the brain and you record their electrical activity, or you have an fMRI, you can kind of look at what tasks are associated with areas of the brain coming on. But it's hard to record one neuron and say the purpose of this one neuron is to do this thing. Whereas if we can record the activity of those neurons not in the brain, but near the organ that they go to, so the heart, for example, or the diaphragm or the lungs, then if a neuron goes into the heart, we can be pretty sure that that neuron has something to do with heart function. And that means we can record its activity, and we do that electrically. We do it electrically. Electrically.
Electronically?
Electrically.
Electrically,
we record. Yeah, so neurons, when a neuron fires, when it sends an electrical impulse, it is an electrical. It's an electrical chemical discharge, but you can detect that electrically with a really simple metal electrode. So if we want to know something about, for example, the neurons that control the heart, then we can dissect out that nerve and stick an electrode on it and record its activity, and then
that's so cool.
We can't show the experiment a bear, but we can change its blood pressure with a drug and see how that affects control of the heart, or we can elicit, if you put cold water on your face, you get what's called a diving response, where your heart slows down, or you can look at how these neurons, which are responsible for controlling one particular organ, and how their electrical activity changes under particular circumstances.
That's so awesome. I love how amazing, the basic fundamental level humans, we're just almost like machines, where we just respond to our environment. There's nothing you can do about it.
We're just a big sack of electrochemical reactions.
Yeah, it's just one walking sack of chemical reactions.
Some are more sacky than others.
Yeah, that's right.
Than others.
Bit more.
And some are a bit smaller and a bit up,
Forever.
Smaller genitals.
Small genitals. Some of us have small genitals. There's nothing wrong with that.
So where in your neuroscience journey did you go, you know what, I'm sick of this technical stuff, I'm going to turn this into a joke. I want to have fun with this. Let's go into science communication and make this a comedy act. A comedy mashup.
I mean, like I say, neuroscience is very serious, and so you might think that in choosing to do something like comedy, I've chosen to become more trivial, but I can reassure you that I have basically always been this way.
That's awesome.
I guess so I did a competition a few years ago called FameLab, which is run by the British Council. It's a kind of 3-minute, no PowerPoint science communication competition, which I won the Victorian heat of, and then I was runner-up in Fremantle at the national final. Sorry, I couldn't get it done for you, Victoria.
Who won it? What state?
I think it was Queensland. I think it was a guy from Newcastle.
That's the worst state.
I think so. He gave a great talk. It was about developing a vaccine for food allergy. It was pretty cool.
Oh, he's kind of cool.
Yeah, so that happened, and I got a real kick out of doing that, and I really liked it, and there was some media associated with that, and I got a kick out of doing that. So, I'm like everyone else. I'm just trying to make myself happy and do what I enjoy and what I think I might be good at. So, yeah, which is a euphemism for I don't know how good a scientist I am. So here I am talking to you.
Oh, we know you're not very good. The fact that you came on the show. No. Well, that's fantastic though, because even like I think that's one of the big problems with science at the moment, and why people are feeling a little bit detached from science is that we're not having people like you out there saying, look, I'm a normal dude here, and I look at the most basic functions of the human brain, and it's so interesting. Pay attention, because sometimes scientists, they're so used to being in their kind of world, their academic world, and obviously they're fantastic at what they do, but sometimes they can forget about the layman. And definitely kind of get that definitely with quantum mechanics and things like that now, where the way really that's going, it's just it's beyond comprehension for most people, scientists even.
I think there was a scientist called Niels Bohr who I think he was the guy who proposed the electron going around the nucleus model of the atom.
Yeah.
But he said something to the effect of, if you think you understand quantum mechanics, you're wrong.
Yeah, that's exactly right.
It's so counterintuitive to us. It's
the communication of science. That's the core of it, isn't it? If you don't effectively communicate the science, it's the same as not actually doing it at all. If no one knows what you're doing, then you're not going to get the funding. People don't see a purpose for your research. They don't see any value in it.
That's exactly
to science.
That's exactly right. And you end up and the evidence of the poor communication is there. We have climate change denialism and anti-vaxxers and God love them, flat earthers.
Oh, we'll talk about that today. How batshit crazy do you need to be to think the Earth's flat?
It's like
incredible.
People have gone above the Earth and taken photographs. Look at the photographs, man.
Yeah. So
that is an extraordinary level of conspiracy, though, to just assuming the Earth was flat to convince most people that it's round. Like,
but what's the purpose of those? Like, NASA's got a conspiracy. What are they gaining out of it? Like,
it's not clear to me at all.
We're just trying to piss them off. Like, do you worry about the way that science literacy is going around the world?
I mean, I have no idea. Like, I'm a scientist, so I don't know what the objective measure of that would be. So whether that was up in the past and down now, I've got absolutely no idea. I suspect there's a lot more science happening now than has ever happened at any time in history, relatively, because there's so many research institutes and so many PhD graduates and those things, and that's great. So I don't know if I'm worried about it. I'm not like, oh, the world is going straight to hell. It used to be great, and now it's terrible. I don't know if I believe that either. I think things are probably generally getting better, but it's certainly something that we should be vigilant about. I think if talking about science is a good thing to do, that's great, because it's something that I enjoy doing. I like being flippant about my life's work.
So maybe you're suggesting perhaps the problem isn't necessarily the science, it's the communication of that science. So we've got that gap in there where academics aren't able to communicate their ideas to people who don't have that background, who can't understand some of those basic scientific principles.
Yeah, I mean, I don't know, because I wasn't around 15 years ago in the same environment, but it seems to me like there are a lot of initiatives to encourage people to talk to the public. There's a lot of media training available. There's a lot of organizations like the British Council and Fresh Science who are trying to facilitate, particularly the young people, the PhD students and the postdocs now, to get out there and talk to the public. And when you publish a paper, make sure you write a press release as well and try and get it in the media so you can tell people about what you're doing. So I think that aspect of it is getting better. Or it's certainly being built into the system now, which I think is fantastic. I think it's a really, really good thing.
Yeah. With your experience with the comedy gigs, would you say there's a big difference between going and hanging around other comedians compared to going and hanging around scientists at a conference?
Yeah. I mean, I didn't meet that many. So I did 3-night run, and I didn't meet a lot of other comedians. I met some, and I saw some really, really good shows. Yeah, I don't know. I mean, I love entertainment, and people love being entertained. And I mean, from my perspective, if you can tap into that and get people to learn anything about what you're actually doing day to day, then that's worthwhile, and it's fun for me, and hopefully it's fun for other people. And you know,
Well, 3 nights sold out. It seems like it was fun.
I had a great time. That is a fun way to spend an hour, and many more times in the future, I hope. I'm currently hoping to organize it for National Science Week, which is happening in August here in Melbourne. Looking for a venue. If anyone listening was really keen to do that.
Fantastic.
Get on board. There's a few venues down here. We love Melbourne. Melbourne's got some great night scenes, great pubs around, plenty of venues.
I do enjoy Melbourne very much.
All right, is there a way people can get in contact with you on Twitter or Facebook if they want to know more?
Yeah, on Twitter I am, for historical reasons, at Ace of Daves. You can get in touch with me about science, about comedy, about anything you like. Where babies come from.
If you'd like to make a baby with me. Oh, mate, thank you so much for joining us today. We really appreciate you coming out, especially we're cooped up in this small hotel room. Check out our view, by the way. That's an amazing view. Look at that.
Oh, wow. That
That's
is some
an
rough
air-conditioning
cast roof and an
system.
aircon.
Yeah, I know.
That's great.
I know. I think there's a hobo that's OD'd in the corner over there.
That's great. You guys are living the life.
Yeah, that's right.
Living the life, yeah.
Whoop, whoop.
So yeah, guys, if you want to check out any of his work, Why You're Not Dead Yet, David, I've looked up a few videos of you and stuff like that. You're around the place on YouTube and things like that. And thanks for doing all the work that you do to help us understand those involuntary actions.
No, thanks for having me. This has been a hoot. Cheers.
Cheers, mate.
Thanks.
Daves.